Thank you for joining. Give it another minute or so and let more people come in. Okay, it's 1 o'clock. We'll get started. Thank you everyone for attending today. My name is Reed Nilsson. I'm a senior field solution architect with CDW, and I'm based in Edmonton, Alberta. So a little bit of background on myself. I've been in IT for about 20 years, started with kind of a jack of all trades, network administrator / database administrator, some web programming. Did that for about 5 years and then moved on to network security. So the last 14 years or so, I've been really focused on network security. So things like firewalls, VPNs, network access control, that sort of thing. So today we're really going to be talking about how IT is really changing around the branch network. So really around how we deploy security to the branch user and how things are changing around that. So we've really seen it over the last year or so with the pandemic and with users moving from working on-prem to working remotely. So we've really seen a lot of users move from being in an office 8 to 5, Monday to Friday, and actually moving to working from home. So when this started about a year ago, we saw a lot of customers were either starting new projects to get people working remotely or just expanding existing remote access networks. So we've done a really good job around that to make sure that as users are out of the office, are able to work from home remotely. And we've done a really good job with that. But as we start to see the vaccine rollouts, we're probably going to start to see more people coming back into the office in the next little while. So now we have to kind of adapt to how users are working remotely today and how they're going to be working from either a mix of in the office and home or in the office completely. So we've really relied heavily on things like Zoom, Teams, WebEx over the last year or so. So we're probably going to see those users as they move from that remote access model, moving back to the office, how we're going to be able to support them using those particular tools. And there are some things around how applications are moving around as well that we really have to adapt our perimeter to supporting both the users, wherever they happen to be, and where the applications are. And realistically, they could be anywhere today too. So how do we adapt to make sure that specifically for the branch network, how do we make sure that those users are protected and secure when they're in the office and able to do their work successfully? So from an agenda perspective, what I'd like to do is just cover off a couple of common architectures that I've seen over the last 15 years or so. So there's 2 of them that are pretty typical. It's not going to be exactly the same as everybody out there, but it's going to be fairly common. And then once we review those common architectures, what kind of challenges we're facing that would affect those particular architectures and how it's changing how we deliver network and security to those branch networks. Once we talk about some of the challenges that we face with those with new business requirements, then we'll talk about how we're actually going to modernize that branch network to make sure that users can work and they can work securely. Then once we kind of cover off that modernization and what that looks like, and some of the considerations, maybe a little bit of gotchas there around what we need to consider if we start modernizing those networks, and then we'll dive into some conclusions at the end. So we do have a Q&A. So for questions, I'd like to hold them to the end. We should have some time at the end. If there are questions, we can cover them, but let's get started. This is fairly typical of MPLS architecture that we've seen deployed probably within the last 10 years or so. So there is still a lot of MPLS out there that customers have. With MPLS, when we look at those particular networks, what's really nice about them is they're able to scale. So we do have that support available from our providers that give us this MPLS service to be able to support large amounts of branch networks. And we do have a little bit of security around it as well, is because these MPLS networks tend to be isolated. They are going to be still running on the same hardware from the ISP, but due to the label switching that we would actually do within the MPLS network, they can actually carve out parts of that network and assign it to you. So when you build a new site, what happens is the service provider is actually going to allocate a new connection for you with new hardware and then join that to your MPLS network. This gives us full mesh within the MPLS network. So if we did have a voice provider or a voice over IP solution where we have branch to branch real-time media streams, or we've got some teleconferencing, we do have that full mesh. But the other thing we have within these networks is the ability to get priority queuing from our service provider. So they can actually allocate a 1 meg bandwidth queue that's going to be priority queued to make sure that we have low latency and guarantees around packet loss for those VoIP connections, for those real-time media streams. The downside with this is, because it's an isolated network, if we want to enable internet connectivity for those branches, and obviously we do, we need to provide that internet connection out of our data centers or some type of hub site. Because we're seeing a lot more traffic leaving the actual perimeter of our organization, so things like Microsoft Teams, Office 365, SaaS applications, we're really seeing more of a demand for internet connectivity from those branch users. Now, what happens is once they want to go to the internet, we would put traffic onto the MPLS network. It's all going to be routed, so it's all based on IP. That traffic has to transit the MPLS network, get to the data center where we would have our perimeter controls, either for internet or possibly some internal segmentation for the data center. But for internet-bound traffic, once we get to the data center, then we go out to the internet. So we do have a little bit of latency involved there, where we have some traffic transiting over that MPLS network to the data center, then out to the internet. In most cases, it's going to be fine. Things like web browsing and that sort of thing, not a big deal. But if we are talking about some of those collaboration tools, then there may be a latency concern. The other thing too with this particular architecture is we do have that increasing bandwidth. So we have to start to build out the MPLS connections to make sure they're sized properly, not just from a branch, but also within the data center. So we have our MPLS connections. If we've got more internet, we're going to have to upgrade those MPLS connections along with the internet connections and any controls that we have at the data center. So if we do have firewalls there and we're doing some URL filtering, TLS decryption, anything like that, we have to make sure those controls are sized properly. From the mesh perspective, it's really nice when we're looking at it from real-time voice. We've got media streams between sites. There is a little bit of a security concern there is we don't really have great controls from those MPLS routers. If we're managing them, we still have some options. Some routers will have stateful packet inspections. We can put some firewalls in there, zone-based firewalls, that kind of thing. But they tend to be a little bit harder to manage because these routers were really built from the ground up to do layer 3 routing. And there wasn't really a good management control plane built onto those routers. So when we're looking at management, we're doing things like SNMP polling. We might be doing some net flow export from those routers to a centralized management controller. But if we want to manage a large number of sites, what we're having to do is either rely on that third-party solution and hope it works, or rely on something like scripting. So we do have some management challenges around this as well. And if we're looking at adding sites, it can take a bit of time for that provider to actually build those sites out. So they do have to provision new connections. Let's say we wanted to stand up either a new data center, or we wanted to do some connectivity to a cloud provider, like we do have the capability for express routes or routes to AWS, and then build them into the MPLS network. But it tends to take a long time to get those built out. So there's a few challenges around this MPLS architecture. So one other common architecture that we see a lot is if we don't have an MPLS network, what we're going to be doing is actually building this connectivity out onto the internet. So instead of having a private network where we're connecting our branches to, we're actually relying on a firewall appliance or some type of VPN termination that goes into the branch site. And each one of those branches would build out an IPsec tunnel from the branch to a data center location, or potentially we could have a full mesh built onto the internet as well, and just have an overlay that we've built out. With a lot of the NGFW vendors out there today, they are going to have management solutions that will allow you to build out these type of architectures fairly easily. So within that management console, we can actually have it built. So we can say we want to have a full mesh, and it will automate that process for you. But if you don't have that solution, building out a full mesh IPsec VPN network statically configured can be a big job, especially if you have 25 sites and you want to add the 26th. Well, that means you're setting up 25 tunnels to build out that new site. The flexibility in this, though, is let's say we did have something we wanted to build out a new cloud provider. A lot of the new firewalls today, they will be, you can virtualize them. So you can actually deploy a new firewall in AWS, in Azure, and then build out that connectivity as well. Or with standard IPsec, they'll all have termination points where you can just bring in a tunnel into that environment. So we do have a lot of flexibility there on how we build this out. What's nice about this as well is from the branch perspective, the firewall itself is right in the branch. So this gives us a bit more security if we want to do something like zoning. So if we did want to have that particular branch network built out, so it has a corporate side and maybe a guest or a PCI environment where we want to have it completely isolated, those NGFWs will have that capability to have that separate zone. If we wanted to do some east-west and do some threat sandboxing, something like that, we can do that within the site as well. And for internet traffic, we have all that going out to the internet. All the controls that we would normally see with firewalls would be built into there as well. So if we did want to do sandboxing or TLS decryption, we could do that right at the site, assuming that we've sized it properly for that particular internet connection. With customers that have these type of solutions, one of the biggest challenges is around consistency around how that particular policy looks like. Part of the challenge is if we've got 20 sites, we've got 20 firewalls. Now, if we can standardize the security policy so it looks the same across all the sites, then it's really good, because then we can say, well, I've got one policy, goes to everybody. And if I want to make a change, let's say I want to add a URL category to a block list, I just do it through my management appliance, push it to all the sites, and we're good. But if we run into the situation where we have some sites, we got 5 sites with this policy, 3 sites with this policy, it can be a little bit onerous to manage that, because every time we want to make a change, we're going into that firewall and it's like one firewall we're going to change, or this firewall. So it becomes a little bit of a management burden if we're not consistent across the board. So these are the two architectures that I would typically see out there today. Now let's talk about some of the challenges that we're running across from a business perspective. So what we're looking at a lot today is around app modernization or digital transformation. So within an organization, they might have concerns around how their application is built today, the hardware it's running on. Maybe they want to make it a little bit more flexible, make it a little bit more cost effective. So when we're looking at options around things like containerization, refactoring, lifting and shifting, all of that type of app migration, so we can actually make it a little bit more flexible. So if we're talking about, let's say we've got a core app and there's a business requirement to actually have it containerized so we can have it be hosted anywhere we want. So we can just deploy containers in AWS, Azure, GCP, wherever it's most cost effective. We're seeing a lot of businesses going down that road. Now with this, with the app modernization, that flexibility brings in some concerns from both the network and security side, because now that app could be anywhere. So today it could be in our data center, and tomorrow it could be somewhere else. So how do we make sure that with the two architectures that we discussed previously, that we've got secure connectivity to those particular applications? Another concern is around data center consolidation. So a lot of organizations are taking a look at their footprint from a real estate perspective, just in general. And data centers are one of them. So either trying to consolidate data centers, reduce the footprint there, or maybe they've got a data center that's on-prem at a building that is being sold, or it's just not cost effective to maintain IT infrastructure within that data center. So they may be looking to move those particular applications to somewhere else. So this could just be a simple lift and shift. So we've got a rack in our headquarters location, and we're just going to move it to a third-party data center because they've got the power and the cooling and the skills to maintain a data center. So again, we run into that problem of applications are moving. How do we get connectivity to them? Cost optimization is one of the big things around MPLS. With MPLS, it tends to be expensive, and the available bandwidth just really isn't there. With customers that are locked into contracts for 5 years with MPLS, they signed it a while ago. So you might be getting some sites with 10 megabits of MPLS connectivity, and that's just not enough. Plus, you're paying a lot of money for it too. So we're seeing with internet connectivity is the cost is really going down, and we're able to get really good speeds from our providers for internet connectivity. So it's less attractive now to look at MPLS compared to internet, because internet's going to be faster and it's going to be cheaper. So why don't we go that direction? But we still have to consider, if we have queues, real-time queues, priority queuing for traffic, how do we make sure that we're able to support that on an internet connection which doesn't have any SLAs on it? Site expansion is one thing as well. So as we kind of move out of the pandemic and hopefully into normal again, I think a lot of organizations are going to be taking a look at either expanding or possibly removing some sites. So how do we get some flexibility around there? And with construction, typically, we're going to see more pop-up sites. So we have a site that we're going to build out, and it's going to live for 6 months, and then it's going to be torn down. In those cases, we don't really want to sign an MPLS contract for 5 years for a site that we expect to live for 6 months, a year. So we want to look at maybe doing some internet connectivity there, or possibly doing something like LTE. So we do have cellular modems available today. Maybe we look at, for some of those sites, maybe we're doing in healthcare, doing a pop-up vaccination site, or with retail, we want to test out a new location. Let's stand up a pop-up site. Let's deploy some hardware with an LTE connection. Test it out, see how it goes. And if it doesn't work, we just reclaim that equipment and we're not tied to a contract for that particular site. Finally, performance. As I said, we've all been pretty reliant on these collaboration tools the last year. So we want to make sure that as users move back on site, that we were able to deliver these particular applications to them just as they were at home. So at home, they might be part of a small family and they've got enough internet connectivity or enough bandwidth to support whatever collaboration tools they're using. But if we have 10 or 15 people in a site all using these collaboration tools and we've got a 10 meg MPLS connection, we might run into a few problems there with some contention. So we want to make sure that the experience for those users as they come back onto the site is still really good, better than what they had at home, hopefully. Finally, over everything here, we still have to consider security because we've seen it recently. Ransomware, it's a big problem. And with moving people back on site, we want to make sure that they're protected and secure, both from their endpoints, but also for them going to the internet or them accessing data center resources. We want to make sure it's all secure. So looking at this particular slide here, with all of these challenges, the customer came to me and said, I've got all this stuff, what do I do? What I would recommend looking at is actually SD-WAN. So from an SD-WAN perspective, you just look at the diagram, it's going to be very similar to your MPLS design. So but what's going to be different is in each one of the branches, we're going to have SD-WAN appliances. So these are going to be the routers handling the outbound connectivity for those users at the site. And instead of relying on a provider to give us the network to build this out, what we're actually going to do is build an overlay on top of the transport. Now we can say transport here because we don't really care what we're building this SD-WAN overlay on top of. It could be internet, it could be MPLS, could be LTE, anything that has connectivity to a data center, we can build an overlay on top of. So what's really nice about that is we get the flexibility. So if we do have some sites that are maybe remote and all we can do is Starlink or LTE, that's fine. As long as we can get some type of network connectivity to them, we can still have that site join into the overlay and be part of our mesh. And from a flexibility perspective too, we do have that capability to build out different kinds of architectures. So really what we're doing with SD-WAN is we're abstracting the network layer and then just building something on top of it that we control through policy. With SD-WAN, everything is going to be centrally managed. So all of those SD-WAN appliances that are out there, what happens is when they power on, they're going to try to dial home to usually a vendor infrastructure that they provide, and then they would be redirected to the SD-WAN infrastructure, your SD-WAN infrastructure. So as a new site comes on board, somebody plugs it into the wall for internet connectivity, and within the SD-WAN management portal, you're going to see that device connect up. And you still have to claim it, and there's still some controls around how those appliances join the mesh. So we're going to be basing it on a UUID or a certificate or something like that. So we don't have to don't have concerns about having rogue devices try to join the SD-WAN overlay. All of the connectivity for this overlay we're building on top of it is all going to be encrypted. So it's going to be secured, typically with AES 256. Each one of the SD-WAN vendors is going to have a different way in how they do that. But at the most fundamental level, we're building a tunnel architecture on top of some type of underlay. So it could be internet, LTE, whatever. So once we've got that built out, then we start to control traffic, not by IP address. We're actually controlling it based on the application type. So this is one of the nice things too about SD-WAN is we do have that capability to stop making decisions about an IP address. So similar to what we saw with next-gen firewalls is instead of basing everything on IP, we start to basing on application. So we can say this particular application, whether it be some type of critical internal application like your ERP or it's VoIP, we can say this VoIP traffic based on the application ID, we're going to treat it with an elevated priority compared to something like web browsing. And then we don't have to know what those IP addresses are. So if we do have applications that are moving around, let's say today our core VoIP application is actually based in our data center, but we've got a good deal from a cloud provider that's going to be offering this particular service, and it's going to be moving tomorrow. We don't really have to concern ourselves about changing a bunch of IP addresses for the routing. We still have to do routing to have the connectivity, but we don't have to start going into the policy to say this particular IP, we have to update it and we have to push all the changes out. So it gives us a lot of flexibility in how things are being moved around. And the other thing too is with that, we get a lot of redundancy and load balancing capabilities. So when we look at MPLS or we look at our firewalls, what they would do from a health checking perspective. So if we did have a couple of links at our remote sites, we would do load balancing either through equal cost, or we would have an active standby link that we would have on our primary link. We would do some type of checking. Usually it's going to be like an ICMP check upstream to either in the next hop or somewhere further in the network. The problem with those on the routers and the next gen firewalls is you may have some soft failures. Let's say you've got some jitter, latency, or packet loss somewhere upstream that the firewall or router isn't able to detect with those those ICMP checks. So we could have a situation where we've got a bad link and our box isn't able to detect it. So we have user traffic being sent over an unreliable link, and then they start to see some problems with their applications. So with SD-WAN, we were able to get a little bit smarter on how those applications are monitored. And it's really going to vary between vendors on how that is handled. Each one is going to have their own way of doing it. Finally, with these SD-WAN appliances, you have the same flexibility for deployments. So they can be hardware appliances or they could be virtual appliances. And even some of the SD-WAN vendors have services available within big data centers that are hosting a lot of cloud providers and be able to build that connectivity out. So you have the ability when you stand up a new SD-WAN appliance, let's say in a new hyperscaler, you can actually define that connectivity by policy and then be able to push that out to all your devices. So if you do have sites that are moving around or standing up, it makes it a lot easier to deploy. When we look at the branch, like I said, we've got the options for multiple internet connections. So we could say we've got internet or LTE, but we do have the flexibility for MPLS as well. So let's say you did have a mix of sites. You've got 20 sites on MPLS. They're part of an existing contract that's still got 3 years to run. We want to keep MPLS for those sites. Maybe we've got some requirements around queuing or something like that for those sites too. But for internet connections at those sites, we want to be able to bring in a new internet connection because it's fairly inexpensive to get that internet connection. We want to bring that into the site as well, and then be able to do load balancing or traffic steering on those links. So if we were looking at one of our pure MPLS or pure IPsec VPN architectures, might get a little bit difficult to manage it, how we steer this traffic. Not impossible, but what we would do is through IPsec VPN, we would have ACLs to say this traffic we want to go over the internet on this particular tunnel. And then for MPLS, if we were doing tunnels there, or maybe an architecture like DMVPN, we would have to do routing and then carefully manage that routing to make sure that the traffic is steering properly. With SD-WAN, what we're able to do is actually define that based on, again, application. And then we have internet links, and we say for internet traffic, we want it to go out that particular link. And then we can assign priority to that as well. So let's say we've got our MPLS connection, we want to use that as the primary for data center traffic. As long as that MPLS link is healthy enough, we can attach jitter, latency, and packet loss requirements around it. So our SD-WAN appliance is able to check that particular link and make sure that it's healthy. So if we have that MPLS link up and running, we're sending traffic over it, the SD-WAN appliance is actually detecting some kind of problem, we can swing that over to our internet connection, use our overlay that's secure tunneled to get that traffic to where it wants to go. With SD-WAN though, if we're talking about pure internet traffic, there is a little bit of concern there because for some of the SD-WAN vendors, they're not going to have the same type of features that are available with a next-gen firewall appliance. So if we're looking to make sure that a user at the branch, if they're going to the internet, typically we would want to have URL filtering, we want to have threats, we want to do some sandboxing there to make sure that that particular endpoint is secure. But from an SD-WAN appliance perspective, it's really good at doing SD-WAN, but it's not really good at doing firewall. So there are some SD-WAN solutions built on firewalls that would have those type of features built in. But if you're looking at SD-WAN, what the solution there is actually to look at a SASE solution. So a secure access services edge. When we're talking about SD-WAN integration with branches, this is really going to be a firewall as a service. And the vendor of that particular SASE solution is going to give you a firewall instance, and then you're going to establish connectivity from all your SD-WAN appliances to that service. And then that service is actually going to give you things like the decryption, the URL filtering, the threat that you would normally see with an on-prem firewall, but now it's going to be hosted in the cloud. Now, you're probably thinking, I've got firewalls on-prem today, why would I do this? Well, there's a couple reasons for it. One is with these SASE services, typically they're going to be licensed just on bandwidth. So you could say to the vendor, I want to get 100 megs of firewall throughput. Like, okay, here's the bill, and away you go. And a lot of times they're not going to be specific about what type of features that you need to support with that 100 megs of throughput. So let's say you wanted to do TLS decryption, which is a little bit of a hairy situation on firewalls or hardware firewalls, because you have to make sure how much traffic are we decrypting, what type of ciphers are we using, that sort of thing. You can just say, whatever, I want to do 100 meg of throughput on a firewall. And they're going to sell you that service, and they're just going to let you run through that particular firewall. And the other thing too is we do have flexibility there on that SASE service is if we do have an increase in bandwidth, we can actually bump it up. So we can say to the vendor, okay, I need an extra 50 or I need an extra 100 meg of throughput. Okay, no problem. They would provision that for you. You don't have to worry about buying new firewalls for an on-prem solution for that. So when we look at the branch, how the user traffic flows is the SD-WAN appliance is going to be making that decision about where to send that traffic. So when we connect up to that SASE service, we're going to be building usually an IPsec tunnel, and depending on the vendor, they may have integrations where they can automatically provision that for you. So instead of going to each box and configuring a tunnel, you just do some configuration in the portal. It builds that tunnel out to the SASE service. And then you define policy to say, for traffic going to the internet or going to SaaS applications, and it doesn't have to be based on IP, that would be really hard, but based on application, SD-WAN appliance is going to get it and going to look at it and say, okay, this is destined for the internet. I'm going to send it out this particular IPsec tunnel. So it's going to go over the tunnel to the SASE provider. They're going to do their firewall filtering as you've configured, and then send it on its way or drop it, depending on what kind of traffic it is. On the other side, for data center traffic, we would still have our policy defined through our management controller to say, this particular application, or you can do it based on subnet if you want, this is actually going to be through my SD-WAN overlay. So the advantage with the SD-WAN overlay is typically on the far side of that, well, always with the SD-WAN overlay, we're going to have another SD-WAN appliance. So we're going to get all those load balancing features and application checking and stuff like that built into the overlay. So we still want to have, if we do have core applications that we're hosting in a data center or hosting in a cloud, usually we want to have an SD-WAN hub or appliance in front of that to make sure we do have those type of features available to us. So if we did have a soft failure somewhere along the line in the provider network, then we're able to do the load balancing or link failover and that kind of thing. So when we're looking at this, we still have to get the traffic somewhere, and that's where we bring in the tunneling. Now, looking at this solution, there's a couple of things to consider. One is licensing. So when we look at SD-WAN solutions, they're typically going to be licensed on bandwidth. So the hardware is going to be fairly inexpensive, but for the SD-WAN optimized traffic, you have to license it based on the bandwidth. So you want to have a good look at what you're looking at for bandwidth requirements. And typically you want to size it on the real traffic and not the links, because you can get 1 gig internet connections nowadays for relatively little money for a site with 10 people. Are they going to be using that gig of traffic? Probably not. So you want to have a good understanding of what you need from a licensing perspective. Now, the other thing too is it's really nice to have a central management controller, but you want to make sure you understand if you're making changes, you can make changes to your entire environment from one spot. So if you are making some routing changes or making policy changes, there's a little bit of concern that that one change could break a lot of things. So you want to make sure you've got a good understanding of what happens with your changes. And finally, from a migration perspective, what it looks like when you're doing that migration. So you've got an MPLS or you've got an IPsec infrastructure today. If you go to this modernization of your branches, what does that migration phase look like? Because you're not going to be able to build in a new SD-WAN infrastructure and tie it into an MPLS with the old routers or IPsec VPN. So there may be a point in time where you're trying to route all this traffic through the data center. So there is some migration concerns there. Probably lots of other considerations, but these are kind of the 3 that I picked out to take a look at. So finally, we really have to consider that the perimeter is dynamic. It could be moving around. Our users could be anywhere, but even looking at the branch, we want to make sure that if we deploy internet connectivity or migrate from internet to MPLS, we want to make sure that we bring that perimeter close to the users, make sure that they're actually still protected. So what's nice about SASE solutions is typically the vendor is going to give you the capability to do remote access clients too. So if you have this SASE solution for users in the branch and then users for remote, they're going to get a very consistent experience, even if they're at home or if they're in the branch. And when we're looking at overall solutions like this, the biggest thing is just to understand the requirements. Try and get as much from the business about what they need, because if you just start with it and I'm just going to do SD-WAN, then you're going to be in a tough spot, because when you start to look at actual vendor solutions, you're not really going to have a good handle on what you need. So there's a ton of SD-WAN vendors out there, and there's a ton of SASE vendors out there too. But if you have a really good understanding of what you're trying to accomplish, then you're able to better map what those requirements are to what the vendor is trying to sell you. And then you're going to have a better understanding of what you're actually going to get into from the solution that you're deploying. I don't see any questions in the Q&A. I'll give it a minute or two, but if you do have any questions after the fact or after this presentation, feel free to reach out. My email's on there. I think I'm probably the only Reed Nilsson on LinkedIn, so feel free to add me to LinkedIn as well. But I just want to say thank you for attending, and there's lots of information there. I hope it was useful and enlightening. Thank you.